The next piece of our algebra review involves combining like terms. We already talked about the difference between variable terms and constant terms. What we need to know now, or review now, is the idea that variable terms can be added together. In this case, example 10 has the variable term 3x and x, and the constant terms plus 2 and minus 9. We can combine the variable terms by adding the coefficients, and we can add the constant terms by adding those values together. But we have one additional step here that we need to take care of before we can start combining those like terms. And that is to use the distributive property to distribute that negative sign, that minus sign, through all of the terms in that second set of parentheses. To do that, we can just drop the parentheses around 3x plus 2 because there's nothing to simplify within them, there's nothing to distribute through in front. But when we start looking at that second expression where we're subtracting x minus 9, now we'll subtract or we'll distribute that negative through, and this will become minus x minus 9, or 3x plus 2 minus x, and then the two negatives will cancel each other out, giving us positive 9. From there, we can look at identifying those like terms to see how we would combine to simplify our problem. First, we look at 3x and minus x, keeping in mind that minus x is the same thing as minus 1 times x. We can add those coefficients together to get positive 2x, and then we can combine our constant terms to get plus 11. So we were able to simplify that more complicated expression down to 2x plus 11. We can do the same in example 11. We'll have 3x squared minus 2. Since there was nothing to distribute through, we can get rid of those parentheses. But then we'll distribute that negative sign, and this will become minus x squared minus negative 11x. So those two negatives will cancel out again, giving us positive 11x, and similarly we'll get positive 11. We can still combine like terms, but we need to pay attention to the variable in our variable terms. In this case, we have 3x squared and minus x squared. That's a different term, or a different variable term, than 11x. So we need to make sure that the variable portion of those variable terms is the same. In this case, we can combine the x squared terms, which will give us, again, positive 2 times x squared. Now we'll look at 11x, which has no like terms because there are no other terms that have just an x. So that will remain unchanged. And then we'll add our constant terms together to get plus 9. So in order for two terms to be like terms, they either need to both be constants or they need to be variable terms that have the exact same variable expression. 11x is not a like term with 3x squared and minus x squared. In example 12, we have a value out in front of those parentheses. So similar to what we did last time, we'll distribute that through. This will become negative 13 times x plus negative 13 times 3, which will give us negative 13x minus 39. We use the distributive property in the same way that we did the previous couple of examples, but in this case we had a number, not just that negative, to distribute through. And I can make that 9 a little clearer. So that should be minus 39. In example 13, we have a slightly different type of problem, but one that hopefully we're familiar with. We have two binomials being multiplied by each other. So a binomial meaning an expression with two terms and then another expression with two terms. When we have something like this, we're still using the distributive property, but an easy way to think of it is the acronym FOIL, where first we'll take the first terms multiplied together. So we'll take the first term of the first binomial, so that's minus 5x, times the first term of the second binomial, 7x. O tells us to multiply together the outside terms, so we'll say plus negative 5x, which is the first term of that first binomial, times 11, the last term of that second binomial, so those are those outside terms, plus the two inside terms, which in this case will be negative 14 and 7x. And then L is the last two terms. We'll take negative 14 times 11. Now we'll go term by term and just simplify each of those expressions by multiplying things together. We'll get negative 5 times 7 will give us negative 35. And since we have x times x, that will become x squared. Our next term will become negative 55x. The third term will become negative 98x. And that last term will become negative 154. In this case, we have two like terms that we can combine, negative 55x and negative 98x. So we can take one last simplification step here to write this as negative 35x squared minus 153x by adding those coefficients together, minus 154. In example 14 and 15, now we're introducing a division symbol. As long as this last statement after the division symbol is just a single term, an easy trick is to just take that first expression and divide every single term by that value that follows the division symbol. So we would rewrite this as 4x squared over 6 plus 8x over 6 plus 2 over 6. So to divide that expression, that first expression by 6 means to just divide each of those expressions, each of those individual terms by 6, and then we'll look at what we can reduce. If we divide 4 by 2, we'll get 2, and dividing 6 by 2 will give us 3. 8 over 6 will reduce to 4 over 3, and 2 over 6 will reduce to 1 over 3, leaving us with 2x squared over 3 plus 4x over 3 plus 1/3. Example 15 will be similar, except that we'll have a little bit more reducing work to do. We'll still take each of the terms in the first expression divided by 6x. We'll look at reducing the numerical portion of each term. So this will reduce to negative 2 over 1, since negative 12 and 6 are both divisible by 6. The second term will reduce to 10 over 3, and the last term will reduce to 2 over 3. Now what we need to do is look at reducing the variable factors. In the first term we have x squared over x. That means one of our x's in the denominator will cancel with one of the x's in the numerator. In the second term, x over x cancels, since anything divided by itself reduces to 1, And then in the last term, there's nothing in the numerator for that x to reduce with. So this will leave us with 2x over 1, negative 2x over 1, minus 10 over 3, plus 2 over 3x, which we could write a little bit more simply as just negative 2x minus 10 over 3 plus 2 over 3x. And just to show you one more equivalent form of the same answer, we can leave those first two terms exactly the same, but looking at that third term where we have 2 over 3x, that would be the same thing as 2 over 3 times 1 over x, if that just ever gets written or formatted a little bit differently.